one more time, with our hybrid model, we have the physical layer, which is concerned with sending zeros and ones through a channel, whether that's a wire, in which case we would use varying voltage to represent what is a 0 and what is a 1. For example, lower voltage is 0, higher voltage is 1. Or if it's through the air, we could use varying frequency of electromagnetic waves that we're sending through the air, or use another method. But for example, lower frequency could be a 0, or higher frequency could be 1, and so forth. With data layer, we start to give some structure to this stream of zeros and ones, so they have beginning and an end, and the data is inside, and there is an address of the sending and receiving machine, and which is the 48-bit hardwired address into the network card. With only these two layers, we can exchange data between two machines. So why do we need the network layer? Do you guys remember last time what was the description of the network layer? What was the network layer doing? Where we were looking at the ALSI reference model, and we did a video case for the ALSI reference model that explained what each layer is doing. Does anybody remember what the network layer does? Okay, so the trick here is that with these two layers, the machines have to be directly connected to each other with a wire or wireless. They cannot have anything else in between them. There cannot be other computers, routers, devices, printers, hotspots, anything like that in between. If we want to be able to exchange data between computers that are far away from each other and there are multiple hops in between, then that's what we need the network layer for. So the network layer, to make that possible, what it does is it creates packets. So the packets would have a special address assigned to them called the IP address, or Internet Protocol address, that allows this layer to route these packets anywhere through a large distance network with many routers and hops in between, because that IP address is unique to identify any device in the world, and these addresses are controlled by a special organization that makes sure there are no two machines that have the same IP address. Another reason is that the network layer does routing. So it implements routers that calculate the routes between the sending and the receiving machine, so they will choose the right path to follow between the sender and the receiver. Other things that this layer is needed for is that it does also congestion control for the network. So let's look at the structure of the network layer. If we see here, it can be viewed as a collection of autonomous systems that are interconnected together. So if we think of the internet, it's basically a network of networks. So it connects a bunch of smaller networks together. And that's what these circles are. These are smaller autonomous systems. By autonomous systems, we mean that they're independent networks, independent of the rest of the networks. But we do connect them together. For example, that's a regional network. That's a local area network for some company. That's a mobile wireless network And then we have transcontinental backbone links that are usually high-speed fiber optics lines or cables that would connect networks between continents and countries. So at the network layer, the internet can be viewed as a collection of networks, also called autonomous systems, that are interconnected. The backbones that I just mentioned, there are just a couple of them. So several backbones exist. Constructed from high bandwidth lines and fast routers. These are called Tier 1 networks. Attached to these backbones are the internet service providers. And the internet service providers will provide access to the network to large data centers, to companies, and also to home users. To regional networks. And attached to these regional networks are the local area networks. So the backbones are these big lines that will connect, let's say, United States to Europe. These little round things here, these are the routers. So the straight lines are the connections of the lines, and the round things are the routers. Every circle represents an independent, smaller network. So that's a regional network that is connected to the backbone through some internet service provider. And to that are connected to local area networks, let's say for homes or for businesses. So all of these are all connected together, and the network layer is responsible for sending the packets from sender to receiver and passing through all of these lines and all of these routers in between until the packet reaches the destination. So the network layer has to compute the path, which is the best, from the sender to the receiver, and make sure that the packet gets there and it's forwarded by every next router on the way. So let's see how it does that.